we go. So that should be my email address, but right after this, I will just be sending you an email, just a normal email without a so like a message attachment. So try that. That should work. I did receive an email from a student previously, also telling me how amazing I am. Thank you. I know I'm amazing now. I enjoy getting messages from my students. And I really do enjoy like interacting with students. So please send me an email. Let me know if that email doesn't work or doesn't work. It's alfred.barnard.extern@srh.de. It's a lot of dots, but it does work. Another thing that somebody has also brought to my attention, sometimes I use strange metaphors, like when I just use a certain words to describe something, like when I try not to use metaphors as much as I can. It's like local sayings we say to describe something. I'm trying to think of something that is not that I do use. So the idea, the point is, sorry, I'm getting lost in my thoughts, is that if I do say something or use language or something that you do not understand, just tell me, what do you mean by this? And I will gladly explain it, hopefully in another way, or something for you to understand. Did I have any more emails? No. Okay, good. Good. Sorry, you're looking at me looking at my emails. It's not really exciting. Okay, so let's continue on. Right, that's what I was thinking about. There's the saying that I sometimes use, and I was going to be using this when we talked about these basic electrical examples. And the saying I was going to be using was, I'm not going to teach you how to suck eggs, which when I mean, which I like I didn't say it, but it just means that I'm not going to teach you something that you already know. So that I might sometimes use language like that, which you won't understand, because why would you? Because it's something that's very local to where I come from. So if I do use language or certain words or a sentence and you don't understand, just let me know and I'll try and explain that. It does happen. I do sometimes use weird language. Right, so let's get back to these, the lecture. And so once again with this is very important to decide, the power consumed and the current running through our circuit. And like I said, you should be able to calculate this relatively easily. But we're not really going to do that because it's not what this class is about. Now, we can also, the reason why I'm not really doing it is that we can use software like Eagle. We can use Eagle to do that, to draw the electric circuit and simulate the circuit. And then after we have simulated our results, make sure that everything is correct, adjusted our trace widths, selected the correct components, then we can transfer it to a PCB design. So in this class, we will not be doing basic electrical calculations. I trust that you can already do that. But what we will do is simulate the circuits. And then once you have simulated the circuits, I just want you to have a look at it and make sure, like, okay, this makes sense, or this answer sounds correct or feels correct. Sometimes the problems that these things make are a lot of the times not really that obvious. So next we're going to talk a little bit about the prototyping phase. How do we end up with a printed circuit board? board, because usually a printed circuit board or a PCB is the end of the product. It's what we end up as, and that's something that we manufacture and then sell or include in our products. But that is not where we start from. We don't start by creating a PCB. We start with creating experimental circuits. Now, it might be some difference in where you do it, or where you do it, or what you do, or how you do it. But generally, for me, the process kind of always ends up being the same. Firstly, I decide what my circuit needs to be doing, right? And that usually ends up with me having an idea. So I would like to have a power delivery circuit that receives 24 volts from a power source like a battery, and then converts it to a 5-volt with a maximum of 2 amperes or something like that. Something like that would be my idea. Then I would usually take a pen and paper and then something like this, and then draw and pencil out my circuit that I would like to design. And then once I have a rough idea of what my circuit should look like, and what components I might need, I will draw a more proper circuit. And now I might be using ELCAD by this point to create what I call my schematic. So a schematic is just a schematic representation of your electrical circuit, where we use the resistor, capacitor, and integrated circuit, or IC, symbols that we spoke about, and everything is connected with lines which represent our electrical connections. Once I have that, and I'm roughly sure that what I'm doing is correct, then I'll move into something I call the prototype phase. And that is when I start building my physical circuit to ensure that what I'm doing is correct. And that usually ends up with me using, well, I'll speak about now. I call it a breadboard. I don't know what the actual other terms is, but it's something like this. It's an electrical board that's got connections, and you insert your electrical components in there and connect it up, and then create your circuit. Well, I'm just summarizing a little bit, and then we'll move into details about what all of this is. And once I have my circuit actually connected and created, I then test it to make sure that it actually does what it says it should do. Because sometimes going from a schematic or a simulation, everything will work, but when you physically build the circuit, some elements might not work as you thought it would. So it's always good to build a prototype. Then I move on to a more permanent prototype, either using something we call variable or strip board, which we'll look at in a second, and then solder in some components. I physically connect them with a soldering iron, which we'll also look at a little bit later. And then once I've tested it again, make sure my circuit is absolutely working, then I can then continue my schematic design and create a printed circuit board from there. So this is usually the process that I personally follow, is I would have a schematic, usually start drawing it by hand, and then transfer it to some program like Eagle to create a more professional schematic. From that schematic, I create my prototype circuit. Now, some people do not use breadboards. They move directly onto variaboards. That is fine, as long as you have some sort of physical test circuit to make sure what you're doing is correct. And once you have physically tested the circuit, it's not just the function, but also the components, then you can go into the more permanent PCB design. And it makes sense to do it like in this testing phase, because if you design the PCB without the physical test and just go off the simulation, it's very easy to make mistakes. So let's jump back to the presentation, we'll talk more in depth about these elements. So I'm sharing my screen again, and this is called a breadboard. Now, some just call it a circuit board. I have no idea why, but I've always been calling this a breadboard. And whoever I spoke to would know this as a breadboard, a bread. So literally a board where you cut bread on. I guess it looks like something that you'd use to cut bread off. I'm not sure, but the name sort of like just stuck, and it's called a breadboard. But you might call it just a circuit board or a temporary circuit board. And it looks roughly like this. So these are usually connected in some sort of proprietary way. On the inside, you can connect your circuits by just simply sticking them in. And it's a temporary circuit, and it's a good and fast way to check that your circuit is working. So on the left side here is how the circuit is connected. All these black lines are connected. At the top, and you have a break in the middle. And on the inside, if you've ever opened these up, these are these physical connections here. So they have these to stick into, and then you use them to create your specific board. Sorry. Because it's usable, it gives you a relatively good set, and then there's no soldering required. You can customize it as you want, and it goes with a multi-board with whatever it needs, task it needs to perform. You can test it before you physically build it. Now, this is not to say that it is limited to simple designs. You can have a wide variety of very complex design. This person on this specific picture built a fully functioning computer, complete with, I think, RAM and all sorts of memory and storage, just using a couple of breadboards. You can have very, very complex designs. I personally like breadboards, just because it's whenever I have an idea of a circuit